In this example, we have to be particularly careful because not only do we have a whole bunch of negative exponents, which are always problematic, we have variable parts in the exponent, and these variables are connected by addition, subtraction, and in this case, multiplication. So you have to be a little bit careful of how we can deal with this. Now, we could separate these because a minus 4 really means divide by x 4 times, and then the a means how often we multiply it by x. But if we apply the exponent rules correctly, we should be able to keep track of this together. We can keep the variable and the number parts together. As long as we keep it organized, we can determine whether we should be adding, subtracting, or in this case, multiplying the exponents together, which is power to power. So I don't like all these negatives, so I think maybe that's the first thing I'm going to deal with here. I just want to make sure I figure out where all these positives and negatives go. And I'm going to work from outside in this case because I can see that if I apply this negative power to that power and the negative power to here, right? I can do that, and I'm not going to distribute into here either, okay? But there's a times in here, so I can apply those powers, and that's going to allow me to get rid of the negative power in the numerator. Now what's going to happen though is I have to apply that across the divide and times here. So I'm going to have to apply it to all 4 parts. So here I'm going to end up with x to the power a minus 4, negative 2 to the power negative 2, divide is times 4. This y to the power negative 2a to the power negative 2, power to power we multiply, divide cancels out to positive 4a. This negative 2 has to apply to the denominator down here, so it's going to be power to power, so we times, and I have to times both terms because this times here is being used divide twice, so it becomes minus 2. So we have to multiply this power to power. Multiplication across addition we have to distribute. And then lastly, this is power to power. We're not going to power this, we're just going to multiply again. Okay, so we end up with negative 6a. So make sure you don't confuse powers. There's no powering up a power. We have power to power, we multiply the powers together. Okay, so I'm going to apply the power to power, so I'm going to multiply these two powers together, which means I distribute across the negative, so it becomes 4a minus 16, y to the 4a, and here I end up with y to the negative 2a minus 2 times x to the negative 6a. Now notice that that's all negative. We should really bring those all into the numerator because these are all divides and it's all in the denominator, so this all should end up being multiplication. So I end up with 4a minus 16 plus, actually maybe I'll do it in steps here, times x to the positive 6a. This is y to the 4a times y to the, I'm going to change that divide to a times and change that divide to a times as well. Or the negative going into the numerator becomes positive. And there is no denominator anymore. So I can combine this up. I can add this together. Well, I'm going to count the a's. Remember, this is counting the multiplications, but I can't count a's and ones the same. I have to count the a's together and the ones together. Same thing here. I count the a's together as 6 a's and the ones together as plus 2. So there's my final answer. Now, if you really wanted to, this is good enough. This is also equivalent to it. Now, that minus 16 really does mean divide, so I could alternatively write it like this. X to the power 10a times y to the power 6a plus 2 divided by, and that x we can actually use that, show that as divide by x 16 times as well. Okay, so this is good enough. Over here, this is perfectly fine. Okay, but this is also an equivalent solution. Okay, those are actually equal to each other.